Hi class, welcome to exercise 4B, finding unknown angles. This will be a fairly quick one, so let's just get straight into it. Your examples and pre-learning for this exercise will be example 3, finding angles. And your pre-learning will be questions 1 and 2 in the new book and question 4 in the old book. And then we'll do example 4, which is working with simple applications. And your pre-learning for this example will be questions 5 in the new book and question 7 in the old book. Alright, I'll see you in the introduction. In the last lesson, we've used angles to find lengths. But in this lesson, we're going to use lengths to find angles. To find angles, we're going to need to use inverse functions. This is a similar concept to how the operation of squaring undoes a square root, and how the operation of a square root undoes squaring. In trigonometry, our definition of inverse functions are when we have our function sine of theta, and a function cos of theta, and a function tan of theta, then you know these are going to equal something, right? Then if we do this inverse function sine to the minus 1 of the sine of theta, then by definition it equals theta. And the same for cos. In other words, inverse cos of theta equals theta, and inverse tan of theta equals theta. So you might call it sine to the minus 1, or arc sine, or inverse sine. These are just different names of the same thing. By definition, this undoes sine, just like the square root undoes the square, or the square undoes square root. And this is the same for what you might call cos to the minus 1, or arc cos, or inverse cos with the function cos. And tan to the minus 1, arc tan, inverse tan with tan. To use these functions, we must use a calculator nearly always. And by calculator, I mean a CAS or scientific calculator. On a calculator, you should look for sine to the minus 1, cos to the minus 1, or tan to the minus 1. They're almost always a second function. And I'll use both the CAS and the scientific in the example so you can see exactly what I mean. Now when we're using these inverse functions, SOHCAHTOA is still really important. So for example, if we were to take this right angled triangle here, with the angle theta, an adjacent side, an opposite side, and a hypotenuse, then sine of theta obviously equals opposite over hypotenuse. So if I apply the inverse function to both sides of this equation, then by definition of the inverse function, the left-hand side of that equation becomes theta. And we're still left with sine to the minus 1 of opposite over hypotenuse on the other side. This means I can use this sine to the minus 1 function to find the angle if I know what the opposite and hypotenuse is. And similarly, if I knew what the adjacent and the hypotenuse is, then because cos of theta is equal to the adjacent over the hypotenuse, then skipping a couple of steps there, we know that theta will be equal to cos to the minus 1 of adjacent over hypotenuse. So in this way, I could find the angle if I know what the adjacent and the hypotenuse is. And once again, with tan of theta equal to opposite over adjacent, if I know what the opposite and adjacent is, I could figure out what the angle is. And when I said earlier that you need to use a calculator, it's once you got to this point where we must put our values in the calculator. Here are some important facts and a chance to try out the calculator. So let's try sine to the minus 1 of 1.1. So here we are with the calculator. As I said, it's a second function. Now pushing that second function and then sine. Now that it's highlighted red, you can see above the sine, there is a sine to the minus 1. Perhaps you can't see it here, but certainly on your calculator you will. Now sine to the minus 1 of 1.1, and we'll close those brackets and press equals. Oh, domain error. What about cos to the minus 1 of 1.1? Also a domain error. Okay, what about tan to the minus 1 of 1.1? Well, there you go. That seems to work out fine. That's given us a value there. So if the opposite divided by the adjacent was 1.1, that must mean that the angle is 47 degrees. Let's go back to OneNote. So we tried sine to the minus 1 of 1.1 and cos to the minus 1 of 1.1. And both of those didn't work. Can you figure out why they don't work? But when we did tan to the minus 1 of 1.1, that was fine. All right, you might want to pause and have a think. These don't work because of the triangle inequality. So if you've got a right angle triangle with side lengths A, O, and H, then the length of the hypotenuse has to be less than the length of the opposite plus the adjacent. That's less than or equal to, sorry. But at the same time, the opposite has to be less than or equal to the hypotenuse, and the adjacent has to be less than or equal to the hypotenuse. So because the opposite is less than the hypotenuse, less than or equal to, then if I divide both sides by the hypotenuse, that means that opposite over hypotenuse has to be less than or equal to 1. And the same for the adjacent. But this restriction doesn't apply to the opposite or the adjacent. So therefore this restriction doesn't apply to tan to the minus 1. So if you ever come to the end of a question and you have sine to the minus 1 of A or cos to the minus 1 of A, and A is greater than 1, then you should stop right there because there has to be an error. All right, let's get on to the next section where we can start with some examples. When finding angles, all we're going to do is use SOHCAHTOA and then we'll find the angle with the inverse operation. Okay, so let's get stuck into example 3, where in part A we have a right angle triangle that has a hypotenuse of 2 and the opposite side to the angle is 1. So considering this angle theta, 1 is the opposite and 2 is the hypotenuse. Therefore, we're going to use SO. So, no pun intended, sine of theta is equal to 1 over 2. In other words, opposite over hypotenuse. And therefore, theta is going to equal sine to the minus 1 over half. So let's use our scientific calculator and clearing up what we did earlier. So sine to the minus 1 over half is equal to 30. So therefore, theta is equal to 30 degrees. Okay, so that was nice and straightforward. Let's go straight on to part B, where we have a right angle triangle. And here we can see this angle theta. Well, the adjacent side to it is 1.5 and the hypotenuse is 2.5. So as I said, 1.5 is the adjacent and 2.5 is the hypotenuse. So we've got adjacent hypotenuse, so we're going to use CA. So by that, I mean cos of theta has to equal adjacent over hypotenuse. And therefore theta has to equal cos to the minus 1 of 1.5 divided by 2.5. And this time, let's use the CAS calculator. So if I press the trig button, which is red, I come up with a bunch of options. So I'm going to choose cos to the minus 1. And that's cos to the minus 1 of 1.5 divided by 2.5. And if you remember from our last lesson, we had to do Control Enter. But notice how we've got decimal places in here. If you do that, the CAS calculator knows that we want a decimal expansion. And we're told we've got 53.130. So let's round that off to 2 decimal places and say that theta is equal to 53.13. All right, that's it. Okay, so after doing our last lesson, this should be really simple. All you're doing is using a different button on the calculator. You just need to be clear how the angle and the side lengths relate together. Okay, so we used the angle to figure out one of the unknown side lengths now. But this inverse operation lets us know what the angle is if we have 2 side lengths in a right angle triangle. All right, you should pause the video now and do questions 1 and 2 if you have the new textbook and question 4 if you have the old textbook. And after you finish those questions, I'll see you in the next section. Inverse trigonometry operations are an important real-world application of trigonometry. And this is because sometimes we can only measure lengths, but we also want to know what the angle is. When you're working on your exercise questions, you need to really read them carefully and make an effort to create a diagram that represents the worded question. All right, so let's have a go at one of these worded questions ourselves with example 4. So in this example, we have a long straight mine tunnel and it's sunk into the ground 120 meters deep. The tunnel ends up being 100 meters horizontally across from the mine entrance. And the question is, what angle does the mine make with the ground? Okay, let's start with a diagram to represent this question. We know that it's 120 meters deep, and we know that the bottom of the mine is horizontally 100 meters from the entrance. So we can draw our long straight mine, and you can see we've created a right angle triangle. Now we wanted to know what angle does this mine make with the ground, and we'll call this angle theta. So if we look at the side lengths of this right angle triangle we've created from theta, 100 meters is adjacent and 120 meters is opposite. So we've got adjacent and opposite, so we're definitely going to use TOA. So therefore, tan of theta has to equal 120 over 100. And we can say that tan of theta is equal to 1.2. So using our inverse operations, theta has to equal inverse tan of 1.2. So to quickly do this on the calculator, we can see that our answer is 50.19 and other stuff. So rounding it off to 2 decimal places, we get 50.19. So because it's a worded question, we should finish with a worded response. So therefore, the tunnel makes an angle of 50.19 degrees with the horizontal ground. Okay, so that's the end of that one. Make sure you do make an effort to read carefully and draw your diagrams for your application questions. But in the meantime, you should pause the video now and have a go at question 5 in the new book or question 7 in the old book. And when you finish that, I'll see you in the summary. So in this lesson, you're beginning to work with applications. And this is really the point of trigonometry. So make sure you don't forget to draw diagrams so that you can see the question. And also make sure that you always use SOHCAHTOA. Alright, so in this lesson, a successful student will know that the inverse trigonometric functions are used to find angles in right-angled triangles, and be able to use the inverse trigonometric functions to find an angle in the right-angled triangle given 2 side lengths. Alright, so they're the 2 main focuses of this lesson. It's a short and sharp lesson, so get on with your pre-learning, and I'll see you in the next video or in class. Bye.